got a warm-up to remind you about chemical formulas. So you're going to want your periodic tables and your naming reference sheets out so that you can perform the warm-up. So what I'm asking you to do is just write the formulas for these 3 chemical compounds. We'll go over it with a class in just a minute. Let's see, thumbs up, thumbs down, some thumbs sideways for naming formula. So the warm-up was designed to catch them exactly where we left off, which was with chemical formulas. The next step in the kind of chemistry progression is to talk about chemical reactions and equations. And this lesson is exactly set up to do just that, to make that transition from formulas to the equations, kind of from chemical words to chemical sentences. The idea that I came up with for this lesson was just that I was seeing students having trouble with the idea of coefficients and subscripts and getting that kind of those 2 numbers mixed up. So what I wanted to do is develop a lesson that kind of targeted helping them understand and get past some of the misconceptions that they were having in a kind of fun and different way. There were things online about making cheeseburgers, but I can't do that in a class, and so the idea of Oreo cookies just kind of came to me. I didn't find it anywhere. It's one of my actual kind of original pieces, so I kind of, like it because it's mine, and I didn't just take it from somebody else. So when we think of an Oreo cookie, we think of, okay, we have one cookie, but that Oreo cookie is made up of different things, right? So what is an Oreo cookie made up of? You can use the board if you need assistance to remember. Mush?
Chocolate cookie and a filling. Or 2 chocolate cookies.
All right, good, good, good. Yes, 2 chocolate cookies and a cream filling. Yeah, no. And so what we see is a regular Oreo cookie would have this kind of chemical notation. 2 chocolate cookies plus cream filling, sticking it together. All right, and that's going to be the key idea here, is in molecules, electrons hold those atoms together into their forms. Here, the cream filling we're treating as an element, but that's going to be what sticks it together. And that's what helps us determine that difference between when we use coefficients and when we use subscripts to show how these kind of chemical formulas work within chemical equations. This is chemistry, which is a high school level class. So most of my students are sophomores or juniors. The state standards are that they need to be able to understand the conservation of mass, they have to be able to balance a chemical equation, they have to be able to recognize chemical formulas, and they have to recognize the different types of chemical reactions that there are. So there's about 5 specific state standards that are based on physical science that I'm targeting in this unit, as well as attempting to weave in some of the math and language standards along with them on a little bit more of a side basis. We'll be having some labs later on, and they have to write lab reports, so that ties in with the kind of writing and focused literacy skills that we need. It really helps explain the difference between coefficients and subscripts. So we use a subscript when things are stuck together. Now, we do not represent 2 Oreo cookies as CK4FI2 because they're not stuck together, right? If I put these 2 Oreo cookies together, will they stick? No, they'll just drop apart. There's nothing to hold them together. So we use a coefficient to show that we have 2 of these molecules, 2 of these things. We don't just use bigger subscripts to show how many pieces we have. It's kind of like if we want to say 2 water molecules, we don't say H4O2, we say 2H2O. Where we also use coefficients is with the leftovers. These 2 chocolate cookies, if we were successful at getting all the cream off, would they stick together? No. So we also use the coefficient to show 2 individual element pieces that also are not stuck together into a bigger molecule, that have no bonds holding them together. But we do use the subscripts on the double stuff Oreo, because on the double stuff Oreo, this cream and these cookies are all going to stick together. So we're going to show. I mean, there's a layer of chemistry that inhabits all parts of our reality. I mean, no matter whether you're going to medicine or automotive, there's going to be aspects of chemistry that enhance and impact what you do. We also are chemical beings. We also eat chemical foods, and we have to make decisions as consumers about what chemicals we have in our environment and what products we end up buying. So the idea behind my class in general is I try to have students get the idea that our first semester and this first part of the second semester is building a chemical tool. So that basically once they understand chemical equations and reactions, they could go out and find one that pertains to something specific to them and understand what it meant and be able to interact with it and actually apply it. So whether they're going into automotive, I mean, all of the equations here are based on the combustion of gasoline. They have to get the oxygen-fuel ratios correct. They're going into cosmetology. They're going to need to know about what are some of the solvents, what are some of the surfactants that they're going to use in washing people's hair, and maybe what are some possible natural ones instead. The idea is to give them the opportunity to learn some chemistry so that they could approach it from an entrepreneurial or personally motivated piece. And then at the end, you have to come up with 3 of your own. And I'd like to see some creativity in the cookie choices that you have so that we can kind of see how that works a little bit better.
When he first started saying, like, it's going to be like some kind of cookie experiment, I had absolutely no idea of, like, cookies. Like, are we baking cookies? What are we doing? And then he introduced kind of a little background knowledge about kind of how to balance equations and what, like, subscripts and coefficients and all that. And I was like, oh, okay, I get this. And then he introduced kind of the cookies and, like, abbreviations, and then when we put everything together, it all made sense. Even though you had, like, cookies and it kind of looked ridiculous, and if anyone walked in the room, they wouldn't know what they were looking at. But it made perfect sense, kind of like breaking them apart, putting them together, and then writing out the abbreviations and actually making it like a chemical formula.
The plus in between, because they're all the same, you just want to show that there's 3 of them. And then so you use the there's the coefficient to tell us we have 3 of these things, and then the arrow to show we're transforming them into something else. Yes, there you go. And we'd want a plus in between here just to show that these 2 things are separate. Perfect.
We had to fill in each equation. We had to write what the formula was for the equation, and then we had to draw out like a diagram of the process of making it. And we added the beginning cookies, and then we showed them being made into what they were, and we had to like draw them out according to like which cookies were which. And then and underneath the drawing, we added the formula corresponding to the picture, and so we could pretty much show what we were doing.
Yeah, so before becoming a teacher, I was actually an analytical chemist in the computer chip industry. So I got to see how chemistry was involved in building the electronic devices that everybody uses and how they work. And I try to bring that practicality to class whenever possible. The only thing here that you're missing is just make sure we have the arrow in this line, because that arrow represents that idea of transformation. We're changing this into that. Okay, good. But you're using your coefficients and subscripts correctly. Good. Well, what I was hoping is that, you know, when students come back from break, they haven't seen people. They want to socialize, and many of them need to. So I want to provide an opportunity for them to do that, but in a more focused way. Because if they're talking about cookies and joking, there's a way for them to talk and make situational comedy and enjoy each other's presence. And then also what I wanted to do was to make sure that I had a chance to individually look at everybody's reactions and make sure they were not mixing up those coefficient subscripts pairing. Making sure that I could individually address those misconceptions in each and every student's group. And I find if students are working on something together, they enjoy it more, and it gives me that ability to float through the room much more easily, seamlessly, pop in, maybe add a joke or something to what was going on, but also make sure that I'm like looking for those key misconceptions that this lesson was designed to kind of support.
Labs are like the funnest thing for me. I absolutely love them. This class has to be one of my favorite classes because of that. What I really admire about him is that he'll make it kind of understanding to like our level. Even though he's a teacher and of course he knows all of this chemistry things, he kind of like starts off really slow for us, and then he makes a lab, and then we have to kind of figure it out, and then he's always there kind of helping you out, seeing if you're doing it correctly. And that's what's nice. Instead of a teacher telling you to like memorize this and memorize that, he helps you understand it and make the connections.
And then you draw this picture and the leftovers. Okay, now you want to separate those with pluses because those are 2 separate things that won't stick together, right? I really enjoy the interaction, attempting to get students to figure out things. It gives me a chance to utilize some of my skills that I didn't get to always use in the laboratory situations, some interpersonal, intrapersonal skills. What I find is that students can be more advanced than I was in high school, but I also find that compared to the amount of work they're prepared to do, it's very different. When I was going through high school, we didn't have as much technology, which impacts how much people feel they need to do to understand it.
it sometimes feels that because at the touch of their fingertips there's this internet that can give them answers, they don't feel the need to make those connections and make it so they can get the answers internally. And so that's one of the most challenging things I've noticed about teaching, and it continues to drift in that direction. Just the interconnected nature of the internet allows people to feel much smarter than perhaps they maybe are, or know more than they maybe actually do. If you look something up on answers.com, you're like, oh, I've got the answer. But if you don't really understand it or know that it's the actual answer to what you're asking about, it doesn't really matter. They can interact with their electronic devices, but they don't know how they actually work. And so to me, for us to move forward as a society, we have to really address that piece and give students more chance to know how things work, and hopefully have that internal so that they can then maybe design better things.
Plus the CK2FI.
But then we end up with one middle and then a double two. See, there's only one.
I'm also in pre-calculus, and I'm seeing that, because pre-calculus I had before chemistry, every time I come from math and like transition to chemistry, it's still kind of the same thing. You're still balancing equations and having little variables here and there. Even though in math it's X and Y, here it's like the dependent, independent. It's the same thing, it all connects virtually.
I mean, it's nice to know just like what our world's made of, and it gives you more of a context as to what is what, like what stuff is made out of in general. And I've always been fascinated by that. Although I'm not going to be a chemist, so it's not going to be as useful, but it'll still be applied in through random ways. Like, how would you know how plants work? That's kind of important, but you wouldn't know without chemistry. Like, it really just explains the world. Even if it doesn't apply to what I want to do, it still shows, hey, I want, like, what is that? I need to know what it is. How does it work? It's our mind and the way it's wired. We just want to know how things are, how it works.
How would we build it?
Most of the designs I saw were literally like a flat board, and then a straight up board, and you had a device that dropped the weight on the piece, a tubing that went up that then launched the ping pong ball out.
He's really a great person. I mean, he's really nice, and he really goes out of his way to like make sure we have fun, but we learn at the same time. His experiments are really fun. We've blown stuff up and lit stuff on fire, but all the while I felt like I was actually learning something that I could apply.
I think at this school we've been able to get the pick of a lot of students or a lot of teachers from around the district. And I think that it shows in the quality of instruction we have at Suncoast Polytech, and just the number of people who have backgrounds that aren't just, you know, going right from college to teaching, but people who've had lives previous to teaching like myself. And I think it shows in the fact that we're able to connect that for students at both the career technical education level and over here in their academic classes as well.
Any remaining questions about cookies? All right. Make sure you eat those up, and I don't want any cookies left, so on the way out somebody can maybe grab those or something.